Hey there. So, yeah, the original title was When Nothing is Just a String, but we changed it so we can do this amazing animation, which should give you a small hint why the title is the way it is, or what our learnings are from building a component library. So that's us. I'm the guy on the right, a little bit photoshopped, Thomas Pink. You can find me on Twitter, but I basically do nothing there except retweeting links so I can store it for later.
Yeah, and my name is Fabian Friedl with the most creative Twitter handle ever. Yes.
Yeah, we both work at Dynatrace, a company you might know. A little bit of advertisement. This is our new office we are building. You might see it when you drive on the highway to Urfa on the left side. It's under construction now, so if you want to work in a great office, you might want to consider this. Yeah, but back to the topic. Why are we building a component library at Dynatrace? So we built a component library at Dynatrace because our new UI is built in Angular, and we wanna support all the 100+ developers, the apps, the teams around the globe and all our locations with standardized components. We are currently 4 team members full-time working on Lint. Actually, we are 6, but 2 of them are part-time, so it's kind of like 4 team members. And we wanna part-time building the library. And we wanna provide high quality, easy to use and consistent components that work on scale. And by scale, I mean scale, so really big. Just for comparison, on our GWT client, we have about 1.5 million lines of code. So our components need to fit a certain performance and scale level.
Yeah, this is our design system. It's called Barista. It's basically our single source of truth, and it contains UI patterns, it contains brand information, and also, of course, our Angular components. And it helps us scale and be consistent and deliver the documentation for all our components. So how does one component page look like in Barista? This is our microchart component, and we always have interactive demos alongside the code that you can just copy and paste and put in your application. We also have our API documentation and some UX guidelines and usage guidelines on how to use those components inside your application. So what have we learned during the last 1.5 years since we started creating this library? The first thing, we learned a lot about API design actually. It's not as simple as it might look at first, and the title should give you a quick, should give you the sneak preview. So what do we mean by that? And best described it, it's by an example. So if you think about the component like a DT card component, a card is basically a container that holds any content and shows some information about the topic. So when we first started creating those components, we talked to UX guys and we talked to PMs, and the message was, okay, the title is just a string. And what happens is, after some time, new UX requirements and new project management requirements get sprinkled on top, and the title becomes something that's not just a string. And that's why we always try to create components with an API that is built for change. So at the beginning, something might be just a string, but things change and requirements change, and that's why we build components like this. We also have another rule in creating the APIs for our components. It stick to what devs already know. So sometimes you have to create Angular components for native-like components, like in select, and we try to stick as close as possible to the native APIs. So every developer in Angular that starts with Angular probably knows HTML. So it's very familiar, and it's easy to use and easy to start with. And we also try to keep APIs consistent as possible across our components. So best case scenario is if you first have a DT card with a title and a subtitle, and sometimes later on, thank you, Pinky, and sometime later on, somebody tells you, okay, this has to be an interactive element, please switch it to a DT tile component. Best case scenario is that the developer doesn't even have to look into our documentation and can just exchange the prefix of the component name, and the API is the same. We also try to build for the data structure we cannot control. So we as component authors, we don't know the data structures that the developers that actually use our components that they need and that they have. So we try to build our components as data structure independent as possible. So we have things like data sources with where the consumer provides us with accessor functions for the stuff that we need, or provides us the data with ng content, or different controls for our tree, for example. So we try to be as independent from the data source as possible, because that's just something we cannot control.
Yeah, so I will talk a bit about contracts, which is basically one of the most important things you have to do when you build a component library. What I mean by that, maybe you know this GIF. Does it start automatically? No. So it shouldn't feel like that. On the one side you have the component library, on the other side you have an Angular app, and they clash together, nothing works. I know the 9gag guys. So you need contracts the app developer can trust. And the first one we have there is prefix everything. Like, you have to choose a prefix for your component. As we already know, namespaces are not there yet. But you have to choose it wisely, because it's a prefix you have to stick around. It's not easy to change, and it will most likely never change. So in our case, we prefix every component with a DT, so the developer knows this is a component by the Dynatrace component library. We prefix every selector, we prefix every CSS selector in the style sheet. The second one is mark internals and privates. Even if you use TypeScript, it is possible that, or it will happen, we see that a lot, that developers will access properties you might don't want to show them, or they shouldn't, like privates, but if you compile it to JavaScript, they can access it. There are also other things like internals. We call internals properties or methods that are on the one side used in the templates. You can't make them private, because then it's not usable in the template. Or fields that are needed for communication between components in the Dynatrace library, but shouldn't be used outside it. So every internal or private we we prefix with an underscore. You might notice from a lot of JavaScript best practices. For us, it has a pretty meaningful meaning behind it. So it's also, when you use it, you see, even if the field is private and it has an underscore on it, the consumer knows, don't use this. This is not part of the public API. This might change. And and it's not part of the contract. Yeah, and the next thing is semantic versioning. Who doesn't know semantic versioning? Maybe then this is for you. Not sure. We can talk later if you want. Yeah, so semantic versioning, as you know, most versions consist of 3 numbers: the first, second, and third number, and they are not just there for fun, as most guys think, maybe on npm. They have a reason. So there is this patch version, and this patch version should increase when you roll out a fix, nothing more. Just some small changes that does not break the API. The minor version should be increased when you roll out the feature. So a new feature you introduce that does not break the API. And the major version should be increased when you do breaking changes. And we stick to this very heavily, and we also try, or we are doing this on a planned basis. So we schedule our releases. The consumer of the component library knows exactly when we increase the major version, when there are breaking changes, they can prepare for it, they can plan their sprints around it. And on this, when doing this, we are predictable, and we are the consumer can easily upgrade our library. And the next big part of it is we do deprecations whenever possible. So when we want to switch the API of a component, and it is possible, which is in 95% of the time, we do a deprecation on the old one, introduce a new API in parallel, and stick to those 2 API possibilities for at least one major version, and in the next major version we will then remove it. You want to continue?
Yeah. Yep. So where will my components be used is a question that you might ask yourself at the beginning. And it's unfortunately, you just don't know. So you have to kind of prepare for the worst. And there are a lot of things to consider. So first, you don't know where your components live inside the application that they are used in. So every one of our components is has change detection set to on push, and to explain a little bit why we need to do this. So this flow shows the basic change detection in Angular without setting any component to on push, and the DT button is our component at the bottom end. So the change detection starts at the root level and then goes down the tree until it reaches our DT button. So if we need to update something on our DT button, everything works fine. But unfortunately, if somebody sets a component that's a parent component of our component to on push, we inherit this. So change detection starts again at the root level, and then no input change. No input might have changed for the component B, so change detection never runs for button. So if you rely on change detection to be run all the time, you can never do any updates. So that's why so the DT button never gets any updates. So that's why we have to prepare for the worst case scenario where our components always live in an on-push environment inside an application. The same goes for preserve whitespace, which might not be that critical, but it's the same. So you get this from your parent component, so that's why we explicitly set it in our components decorator to on push and preserve whitespace to false. So you wanna, you also don't know where or on which platform your applications might be running. So with Angular Universal, your application might be built for the first render on in a Node.js environment. You also don't know if it's run in the browser or a worker. So that's why you should avoid at all costs to access the DOM directly, or at least have checks before you do this. So you can render your components all in a universal or in a worker environment. And that's why Angular provides you with an abstraction layer to access those DOM native features like create element or add classes or remove classes to components from elements. And you also don't even know in which ecosystem or surrounding ecosystem your app might be running. And that's why you have to ship your Angular library in a certain way. And there is a Angular package format Google document by the Angular core team, which describes all the necessary files, all the necessary ECMAScript modules and flat ECMAScript modules that you have to ship to be independent of the ecosystem where your components are running. So if you want to do rapid prototyping in Plunk and Fiddle, you have to provide UMD bundles that can just be used in a script tag, for instance. And you also have to ship the typings and the meta information, for instance, for the AOT compilation. And our journey started in January 2018 to actually get to this output, to the output that meets the criteria for the Angular package format. And at first we had custom tooling, which was, of course, more bugs more code written by us, so more bugs, more stuff to maintain ourselves, and it was kind of tedious. And in March 2018, there was we heard from of a third-party library called ngpackager, and we said, okay, let's switch to ngpackager. But unfortunately, our library was already that big that we ran into a lot of problems with ngpackager. It was pretty early on in the life cycle of this library, and we had to battle a lot of issues regarding memory leaks because of the size and amount of components that we have in our library. But thanks to the guys that work on the Angular CLI, in May 2018, the CLI included the ngpackager, and at that point, the ngpackager became more stable and stable with every released version. So every developer can now, and could also in May 2018, create their own library that meets all those requirements of the Angular package format, so that you can run and include your library in any environment, in any ecosystem, and build it with AOT and have typings for your TypeScript environment. So now you can build your own. It's easy to use and it's quite stable. So we didn't really have any issues in the last couple of months. So it's really stable, and everybody can now simply use this ng-generate library functionality that's now built into the CLI.
Yeah, and a very big part of developing those components in the library is the Angular development kit. You might have heard of it. It provides a big set of patterns, of abstract components you could extend on services you could use for basically a lot, or basically everything you can imagine. No, it's a bit overwhelming, but a lot of features you might know, like tables, like trees, like also accessibility functions. It's a big part of our development, and you definitely have to take a look into this if you are doing Angular component development. And what we didn't consider at first, but that's now also a big part of maintaining this library, is the documentation and guidelines. We started with a very minimal set and quickly recognized that we need more guides, we need more documentation, so the developer know exactly how to use the component, and even when to use the component, because we saw a lot of misuse of some components, like for example the DT card that basically has a title, a subtitle, and a content. We saw it used in a like video player, where they put the controls in the title, the progress bar in the subtitle, and the video in the content. And yeah, for us it's a challenge to make this more clear, also when a component should be used, so that it makes sense and so that it is accessible. And what you also have to take care of is to onboard new developers, and we treat this component library basically like an open source project. So we also have guidelines how you or other developers can contribute to the library, how they are getting started in the development process, and so on. So prepare a lot of time to invest into managing a community. Treat it like an open source project, and yeah, the rest fell together. So the key takeaways?
Yeah, so our key takeaways for you, what we have learned summarized is try to provide a good developer experience. So this means good consistent APIs, good documentation, so it's easy to use, and it's every developer that needs some information has a place where they can go and where they can find those informations. And another thing is program defensively. So if you think about think back to the example that we showed with the string, try to prepare for the worst case, try to prepare for change and for the unknown as well, because you don't know where your components are running. So program as defensively as possible, and be open and transparent. So try to communicate. Try to be out in the open about your versioning, about your planned releases, and also about your APIs. So we are writing API proposals for every new component, and even we try to even write API proposals for small changes or small feature enhancements for our existing components. So we do this all in our Jira that's available for all our developers, and we post this on our in Slack channels. So every developer that might be doing Java right now has a chance to actually contribute to the API changes and to the new APIs of new existing of new components. So we get all the different use cases that not even our UX guys might think of at the beginning. So I guess.
Thank you. Yeah, that's basically our talk. If you want to look into it, at barista.dynatrace.com, you find an open variant of our design system. Again, we are hiring. Join the team. We need more developers. And yeah, that's us, and thank you.